In Fig, let the mass of the block be 8.5 kg and the angle theta be 30 degrees. Find the tension in the cord and the normal force acting on the block. If the cord is cut, find the magnitude of the resulting acceleration of the block. Let's check the external forces applied to this block object. There are 3 external forces acting on the block. First, this block is placed on a ramp inclined plane at angle 30 degrees. This angle is 30 degrees. The plane is frictionless. The ramp applied to this ramp is applied to the block. It's normal force. The normal force is always perpendicular to the surface. So this perpendicular to surface, they press acting each other. So this normal force should be the direction of perpendicular to surface, which is perpendicular to here. Okay, so perpendicular to surface, that's normal force. Always perpendicular to this attached surface. Second, okay, let's write this is the normal force. And the second, the tension force. The cord pulls the block with the force directed away from the body and along the cord. So this is this direction. This is a tension force. And the third, the gravitational force toward center of the earth. That will be perpendicular in the vertical. That will be gravitational force. I draw a free body diagram here on the bottom. Here's a free diagram body. This one is normal force. This is a normal force. And this one is, and the normal force is always perpendicular to surface. Next, this is a tension force. Tension force, or I can write as tension force. That is the tension force is in the from the cord. From the cord, that is always in direction away the body and along the cord. Third one, gravitational force. This is a gravitational force. This one is a gravitational force. That's a gravitational force. These 3 forces apply to the block here. According to Newton's first law, if no net force acts on a body, the body's velocity cannot change. That is, the body cannot accelerate. Please type 1 in the comment if you need to review the Newton's law. I'll send you a link for the review materials and the practice questions for free. Okay, let's continue. The block in this figure is at rest, no acceleration. That means the net force of these 3 forces is 0. Let's try to solve the problem. A. Find the tension in cord. First, we're going to separate these axes, but not the typical XYZ coordinate system. We're going to separate along the chord direction or along the inclined surface direction and perpendicular to its surface. Why don't we separate the axis to the typical XYZ coordinate? I'm going to talk about later. The normal force is perpendicular to inclined surface. This is perpendicular to inclined surface, and the tension cord is along the inclined surface. We only need a separate gravitational force to the two axes. This gravitational force is separate them along this inclined surface. This is one component, and another one is this perpendicular to this surface. This is another component. I separate them. It's this one. Here's one. The coordinate along the surface, we can see there's two forces on this object, on this coordinate. Tension force, this tension force is another one. Here is the component of the gravitational force. These two forces are the same magnitude and opposite direction. So we just need to calculate the component of the gravitational force to find out tension force. So this angle is originally said this is 30 degree. This is 30 degree. That means this angle is 30 degree and this will be 60 degree. We are calculating this component. So I'm going to calculate the tension force is opposite from this the component of opposite direction. So tension force is equal to component of this force. So I'm going to calculate this is a 60 degree, and I make this is 30 degree. This will be 30 degree. Therefore, this is a gravitational force multiplied by sine 30 degree. So gravitational force I can calculate by 8.5 kilogram, which this block is 8.5 kilogram, and free fall acceleration is 9.8 meters per second square times sine 30 degree. So we can calculate by this 41.65 Newton. As you can round it to 42 Newton. That's the first question. The second question, they're asking the normal force acting on the block. The normal force, we know that we already analyzed earlier. This is normal force on the block. But the same concept, normal force and this gravitational force along this coordinate, they are the same magnitude and the opposite direction. So we're going to calculate the component of the gravitational force to find the magnitude of this normal force. So gravitational and the normal force should be equal to gravitational force component along this perpendicular to the surface, or we can see on the bottom is this graph. We need to calculate this. This time we have the cosine 30 degree. Therefore, normal force cosine 30 degree this is a way to calculate second question. The gravitational force we always can calculate by mass multiplied by acceleration. In this free fall acceleration multiplied by cosine 30 degree. Mass is 8.5 kilogram, and the gravitation and the free fall acceleration is 9.8 meters per second square, and the cosine 30 degree, the calculate we can have about 72.14 Newton, or you can just simplify 72 Newton. Third question, if the cord is cut, find the magnitude of the resulting acceleration of the block. So that if the situation, this part of the cord is gone, then along this surface, this direction, we only have one direction power go downward along the inclined surface. So we won't using that power, the force divided by the mass, we can find out acceleration. They asking the cord cut with acceleration. Acceleration we can calculate by the force divided by the mass. So our force, that force, the component of gravitational force, therefore gravitational force was a sine 30 degree divided by the mass. But as you know, the gravitational force we can calculate by mass times the free fall acceleration g multiplied by sine 30 degree was we want to divide by the mass, so these two cancel out. Basically it's g, the free fall acceleration, times sine 30 degree. This will be the 9.8 meter per second square multiplied by 1/2. Therefore, answer should be 4.9 meters per second square. We already solved this question. So we found out the tension in the cord and the normal force, and we also find out the magnitude of resulting the acceleration. But do not stop here. If you want to learn effectively, you need to practicing posing questions and seeing if you can solve them in different ways or think from different perspectives. That's the key to distinguish level of learning. Let's think about, does it still work if they separate the axis in typical XYZ coordinate system? If our calculation still works or not? So this time, 3 different forces. I won't separate them in the XYZ coordinate system. So first, our gravitational force is gravitational force. We were calculating by the mass multiplied the free fall acceleration. So this will be 8.5 kilogram multiplied by our gravitation. The free fall acceleration is 9.8 meter per second square. So that is 83.3 Newton. And this force, we already calculated this will be tension force. We have here 41.65 Newton. So I want this is a tension force on the x component. I can calculate x component by tension force multiplied by cosine 30 degree, which 41.65 Newton times cosine 30 degree. I'm going to get 36.07 Newton. That's the about. And for this part, this is a y component. This one tension force y component. I can calculate tension force times sine 30 degree. That should be 20.825 Newton. That was a tension force. Now we want to check this is a normal force. The normal force we calculated earlier was 72. That was 72.14 Newton. In order to find that the x component of this, the force x component, I'm calculating by the normal force times sine 30 degree. That will be 36.07. And the normal force y component, I can normal force times cosine 30 degree. That will be about 70. No, that's not right. 62.48 Newton. Now we want the total force for y-axis. Okay, so check y component of the net force. Y component net force is this y component net force, this y component net force, and this y component net force. So net force y component, so 62.48 plus 20.825, and this gravitational force will be negative, so minus 83.3 Newton. That because a rounding number have a little difference, but it is 62.48 plus 20.825 minus 83.3. Yes, because of the rounded number, this isn't the 0.005. Yeah, there's a point in the rounded number. That's why this isn't, we can round it to 0 Newton. That's the first in the y component. Net force is 0. Good. And we want to see x component. X component, we have here's x component, we have x component is here. That's already proved because x component of this body force applied to this body only 2. So that's from 1 from the normal force, 1 is from the tension force. That's the both is the opposite direction. Their same power 36.05. That's correct. Okay, so as a result, if you guys need help on any other, please leave a comment on the below, or please type 2 trick in the comment if you need to review the basic trigonometry. I'll send you a link for the review materials and the practice question for free. See you next time on the next video. Bye.